An industrial robot begins long before it ever moves on a factory floor. Automation starts with materials. In robotics, accuracy begins at the smallest interfaces.
A robot is designed as mechanics, electronics, and motion logic at the same time.
Every axis has to become one coordinated machine. This is where raw metal begins learning the geometry of motion.
Smooth motion later depends on exact surfaces now.
A stable robot is built around controlled rotation. What looks invisible inside the joint will decide precision on the line. A robot moves only as well as its servo system can command force. In industrial motion, power is nothing without it. A robot only knows where it is.
Mechanical precision means little without correct control.
Modern robots are as much signal architecture as metal.
Each joint is a machine inside the machine. Repeatability is earned in the details nobody sees after assembly. Every precise movement starts from a base that refuses to drift. Now the robot starts becoming recognizable as an arm. Flexibility in motion depends on discipline in assembly. The wrist is where raw reach becomes dexterity. This is the moment separate axes become one robotic body. A robot's elegance depends on how well movement and wiring coexist.
The arm moves in the cell, but the decisions begin in the cabinet.
Industrial robots are trusted only when people can command and stop them safely.
Before it moves, the machine has to prove it can wait correctly.
The first movement is not speed, it is self-awareness. A robot becomes trustworthy when motion agrees with measurement.
This is where assembly turns into choreography.
A robot is only real when it can carry the work it was built for. In industry, being right once is not enough. Reliability is measured over time, not just at startup.
A powerful robot is only valuable when it can work safely near risk.
A robot arm becomes useful only when it can meet the task at the flange. The hand defines how the robot touches the world. Modern automation increasingly depends on seeing as well as moving. A robot is not just delivered, it is deployed into a working ecosystem. Control survives it. In many factories, repeatable skill is exactly what automation buys. Automation becomes valuable when it serves the whole process, not just one motion. The same logic that handles steel can also handle fragile detail.
The goal is not to remove people, but to give dangerous repetition to machines.
Industrial trust is built on repeatability, but business value is built on optimization. A finished robot is documented into trust.
Consistency at scale is what turns engineering into manufacturing confidence.
Precision has to survive transport before it can survive production. The robot is built in one place, but meant to work somewhere else. The story only becomes complete when the robot meets the factory it will serve. A robot works best when it is integrated, not just placed.
Real automation starts when machines agree on timing.
Every useful robot has to be taught its world.
This is where the robot stops being a product and becomes production.
The highest compliment to industrial automation is that it becomes normal. Machines create value when they support the rhythm of human work. Precision becomes trust when it shows up in output. Reliable automation is protected by disciplined maintenance. The smartest industrial machines do not just work, they report how they are aging. Versatility is where robotics moves from automation to strategic value.
One robotic platform can many kinds of industry.
Automation becomes even more valuable where contamination and industrial robotics spans both delicacy and strength. The best automation changes with the work instead of blocking it. Trust in automation eventually shows up in numbers.
Some of the biggest value in robotics comes while the rest of the building is quieter.
Automation matters only when it feeds the next step correctly.
Others. A robot creates trust fastest when the people around it understand it.
Reliability is not the absence of interruption. It is the quality of recovery.
Behind every robot is a community of skill most never see. Real value appears when every stage remains connected all the way to production. One robot is useful. A connected factory multiplies that usefulness.
Industrial robotics is not one story. It is many industries sharing the same need for repeatable precision. Good origin, correct assembly, proven motion, real factory work, and long support. This is how trust grows in industrial robotics. A robot becomes believable when engineering, safety, and work all agree.
The strongest automation is the kind people can support with confidence.
The best machines do not need to appear heroic. They need to be ready again tomorrow.
Modern industrial trust grows from connected visibility. A robot's value built with equal care. Automation matters most when it can improve the factories that already exist. Industrial robotics becomes powerful when it fits more than large corporations. The next layer of trust comes from predicting problems before metal moves. The best automation of the future will be judged by both output and efficiency. Most people never see the robot, but they live among what it helps make. The highest success of industrial robotics is often hidden in product quality. Factory precision becomes social value when it reaches real life.
The machine becomes successful when people stop doubting it and start depending on it.
Trust in automation is built one correct cycle from raw metal to real production. Every stage matters because every stage supports the next.
From precision parts to trusted factory work, an industrial robot creates value through correct engineering.
That's it for this episode. Thanks for watching. We hope this gave you a deeper look at how real quality is made and quality and why trust matters.